Roorkee. Professor Singh research interests are centered around composite materials, including their conceptualization and development, manufacturing of polymer and metal matrix composites, and natural fiber-based green composites. His educational journey began at NIT Hamirpur, where he earned his BTech degree in mechanical engineering in 1998. He then completed his MTech in production engineering in 2000 and his PhD in mechanical engineering in 2004, both from IIT Delhi. Professor Singh's exemplary contributions to education and research have been recognized with several honors. He received the Outstanding Teacher Award from IIT Roorkee in 2013, the Foundation for Innovation and Technology Transfer Award for Best Industry Relevant Doctoral Thesis from IIT Delhi in 2005, and was named Outstanding Sportsperson of the Year by IIT Delhi in 2000. He has published numerous research papers that has significantly advanced the field of composite materials. Today, Professor Singh will be delivering a talk on sustainable composite materials, concept to product realization. This topic is of great relevance as we explore the development and application of sustainable materials in our industry. We welcome you, sir.
Okay, I think we are at the cusp of noon, so good noon to all of you. I'm happy to see a great number of interested delegates from academia, industry, as well as some students who have shown interest to attend academic lecture. At the onset, I'm thankful to the organizers, Dr. R.K. Singh, Ahmedabad University, Professor Sunil Kale, for giving me this opportunity to come here and discuss what we are doing at IIT Roorkee in the field of composite materials. A lot has been said in the previous session. Since this is the first academic session, I will start from the concept and finally lead to the product realization. As this conference is focused more on industry, I will try to emphasize more on the application part of the composite materials and the manufacturing aspects rather than going into the characterization and testing and analysis, because here our target is to see what is a composite material and how it can be used for making money. So commercialization is more important when industry is involved. So instead of putting my academic lecture in terms of lot of testing results, this is the strength is improving, thermal properties are like this, flammability can be improved using this is a flame retardant. I have not clubbed anything of that sort into my lecture. It is a purely, you can say, industry specific lecture where we talk about the need, where when you go and sell a composite product, the type of questions people will ask you in terms of cost, in terms of sustainability, in terms of relevance, and then how you can make composite materials, some of the products that we have made at IIT Roorkee, which can be commercialized. And finally, I will end up with something where there can be other efforts that can be put up. To start with, I will try to be well within my limits rather than limits in terms of time, so that we are able to follow the time schedule laid out by the organizers. First thing first, why sustainable? And if you see the title, there are two words which are green. First one is the sustainable and second one is the product. So finally now there is a lot of emphasis on making products which are close to the nature. And we are seeing right now also the climate change that is happening. And since I come from Uttarakhand and the neighboring Himachal Pradesh, I belong to Himachal, serving in Uttarakhand, two border states, but we are seeing what devastation the climate change can cause. and why our products need to be sustainable, that we need to understand. From that point of view, we have to see that why sustainability is an important issue. Now, 2017 at IIT Hyderabad, there was a conference, and I think which was the most well-attended conference I have seen in our country in 2017. There were around 600 delegates, everyone working in the field of composite materials, and out of those, I think more than 25% delegates came from the other countries. Normally, we call a conference as an international conference, but then we have only a handful of delegates from the foreign nationalities. Most of the delegates who with Indian origin only, they come back to visit India, and then we say it is an international conference. But that conference was purely international in all its aspects. So finally, there was a panel discussion in which all experts, right from Japan to Canada, all people who are working in composite materials for last 30 years, they sat down on the dais like we had a discussion today morning, and they were given a task, what would be the future of composites. And I am not talking about 2001, 2003, I am talking about 2017. So hardly 6-7 years back, this panel discussion took place. People who have published more than maybe 500 research articles in the field of composite materials. Professor J.N. Reddy was there, a most cited Indian in the field of, you can say, science and engineering. Professor Reddy was there, then his students were there who have also retired from different US universities. So all these stalwarts were there, and I was also there in the audience. Three things came up for the future of the composite industry. First thing, many of them have already worked in the theoretical aspects of composites, as in the morning it was pointed out that we need to do the design part of the composites and then the technology development in the field of composites. So the design is a major, you can say, hindrance than when we talk about the application, because you need to have a sound design which can then be fabricated into a product. So the first thing that came up was the design. Now, design that is done, lot of analysis has been done, which is purely theoretical in nature, analytical in nature. So every expert pointed out that this design has to be validated using the experiments. Now, a design may be suggesting something, the nose shape must be this, thickness of the composite must be this, but it has to be experimentally validated, because whatever we design, when you fabricate it, many things will change. And their process-induced imperfections or defects that we call, those will creep in when you try to manufacture it. So whatever design states, you have to experimentally validate it. That was the first important outcome, or first important, you can say, highlight of the panel discussion. Second important was the volume. In the morning, we had a great presentation for ISRO. The composites were developed for the aircraft industry for lightweight applications. All of us have understood it. Now, lightweight applications, if we talk about how many aircrafts we are manufacturing in the world. So if the composites are only going to be used for manufacturing of aircrafts, the volume will always be low. Even if we talk about spacecrafts or rockets, whatever application we take, high-end application, the volume of material required will be significantly less. I am going to talk about material to your bathroom. When you go in the morning to brush your teeth, you use a plastic handled toothbrush. If we can reach to that level of application of composite materials, then the volume will significantly grow, and we will start seeing composites all around us. It's not only in the aircraft industry or in the space industry where the composites can find application. They can find application in day-to-day products also. I'm talking about a toothbrush handle which can be easily made with a composite material, which can be a thermoplastic. Most of that industry in India, as I see, are focusing on thermosets. The thermosets are also going to be very soon replaced by thermoplastics, because now we have three things, 3 R's of sustainability. All of you know, reduce, reuse and recycle. Now thermoplastics are easy to recycle as compared to the thermosets. So in future we will see many applications where the thermosets will be replaced by the thermoplastics. So that was the second aspect which came out, that whatever we are doing, we should try to increase the volume of composites in our day-to-day life, or volume of consumption of composites in our day-to-day. And the third thing that came out was, which has also been highlighted in the morning, that who will make composites. And if you use a composite product, who will repair it once it is damaged? So there has to be a skilled manpower or at the grassroots level which can help us in repairing the composites. In the morning there was discussion on pre-pegs. Now pre-pegs are not manufactured in India, they are bought, the cost is very high. Second thing is, even to maintain them, you have to maintain a temperature minus 16, minus to keep them in a state in which they can be reused, or they can be used whenever there is a need or requirement. So not only pre-pegs, buying of pre-pegs, but also maintaining the pre-pegs in the state is also a challenging task. You have environment. So we have to have people who will be experts in the field of composites, not only from manufacturing point of view, but from repair point of view. So there need to be a skilled manpower, and to till date, we don't have even a single UG program focusing on composites, and I am very happy to note that Ahmedabad University has decided to start a PG program in the field of composite materials. So at least at IIT Roorkee also, we are in the process of discussion with a team at IIT Delhi to lead a joint program in the field of composite materials. Rather than starting a master's program in composite material, we are planning to establish a center for composite materials where the diverse experts from different disciplines and different departments can collaborate. Now this is an interdisciplinary field. If you talk about a polymer, you need to have a chemist or a chemical engineer who has all the details about the polymer. If you talk about fibers, again you need experts from textiles, as in the morning we have heard a lecture from the director from Atira. So here then you need to have a mechanical engineer who will bring these two things together, the polymer and the fiber together, to make a good quality composite material. Then once the composite has been made, you need someone who will test it. And then after testing, there has to be a techno-commercial evaluation whether this will be able to satisfy the commercial viability of the product in the market or not. So you need to have someone who will have, as Mr. Tyagi was there in the morning, who is a business head, to see how you can make money out of making a composite or fabricating a composite product. So I will restrict myself in the presentation to what we are doing at IIT Roorkee and why sustainable products are important and are going to be the future. Here also you see things have started to change. When we used to attend a conference 10 years back, 15 years back, all these bottles used to be plastic bottles on the table. Now you see glass bottles. So things have to change right at the grassroots level to make an impact. Other than we can discuss so many things, but when nothing happens on ground, normally we lose hope. So we have to see, with little modifications in our day-to-day life, we can easily replace one of the most damaging materials for the environment, which is a polymer. I think, Mr. Pavan, please excuse me, because Reliance Polymers is doing good business, but in future we have to see that how Reliance can bring in biopolymers into our day-to-day consumption, so that which are easy to recycle, easy to degrade, easy to sometimes if possible biodegrade. So we have to see that materials at the end of life. Not yesterday, 2 days back, we had a speaker from University of Akron, Ohio, Professor Ajay Mahajan, who happens to be from IIT Delhi. He has worked for the racing car for Schumacher. So he said, he was discussing in one of the discussions, what is an ideal sports car? In the morning, that discussion has already come up. What is the recyclable satellites? In the morning, Director Sir was pointing out recyclable, reusable satellites. So from there, that thought crossed my mind that Professor Ajay Mahajan was talking about what is an ideal sports car. He told the manufacturer told him that the ideal sports car is a car which ends the race without even a single drop of gasoline or the fuel left in it, and it automatically disintegrates into the part after crossing the line. Now that is the ideal scenario. A racing car, driver gets out, maybe in next 10 minutes it disintegrates into the different parts, and all these parts are recyclable, reusable, and these can be easily disposed of. And then you can reuse these parts to make a new car. So that is the ideal scenario of products that we are trying to conceptualize. For example, here also, for composite materials also, once the product has lived its life, we have to find out means and mechanisms to see what happens to the products at the end of life. So just I have taken an example of a racing car which also uses lot of composite materials, because you need to reduce the weight of the car significantly to improve its one is the speed and another one is the fuel efficiency. So concept of composite materials, I believe, is known to all of you. Now I will just try to focus on one or two slides what is the basic concept, because I start with concept, then finally to the products and what are the challenges with sustainability. Just one or two slides I will try to emphasize on that. So this is a well-known definition of sustainability given by the UN, and we need to be sustainable on all fronts: economical, social, and more importantly on environmental context, because there are limited resources, limited space, limited time, and so on and so forth. Not changing. Now it is. It will take some time. Pointer, I think, is not working. Okay, now it is working. Okay, so I was here, so I think I had to point it this way. So this is the context in which I am going to speak. Now we have a concept of design for excellence, because when we talk of a product, then we talk about manufacturing, a design of the product, then manufacturing, and then using the product. So first thing comes in a product development cycle is that design. So this design for excellence is a, you can say, well-known concept. So what excellence means, X can be a variable. So X can have different aspects as mentioned there. It can be manufacturing, cost, quality, assembly, sustainability. Sustainability I have definitely put in green because that is the title of the talk today. And if these guidelines we are not focusing. Now in design for excellence, what is the basic concept that when we are selecting a product or making a product or thinking that this product we have to make, we have to focus on all these aspects: the cost, the quality, the manufacturing, the assembly, the sustainability, and we have to come up with a solution which makes a trade-off among all these different aspects. For example, for aerospace industry, one of the important aspects can be the weight. Since morning when all speakers have focused on the weight, so weight can be one of the parameters for a product which has to be used in aircraft industry. And in one of the books it is written that if you are able to save 1 kg weight of an aircraft, you can save 6 gallons of fuel. So that is the kind of advantage, the you can say indirect advantage you gain by reducing the weight of an aircraft. So what I am trying to emphasize is focusing on the product, what is going. For example, you want to make a toothbrush handle, maybe weight may not be a very important criteria there, because already it is lightweight, it is a plastic. Then you are making a composite. Target can be sustainability. Even there is a design in which a toothbrush handle can be used multiple times, only the part with the bristles will change. It can be screwed or joined using any type of arrangement with the handle. So handle you can reuse it multiple times, only the bristles part you change as per the advice of the doctor, maybe after every 3 months. So that is when you are designing a product, you have to see that what are the focus areas for that product. It can be cost, it can be reliability, it can be quality, it can be assembly, it can be manufacturing, it can be sustainability, it can be environment. So that we have to keep in mind. And if we don't follow these guidelines, what can happen? Many products, if you Google or you go to YouTube, put failed products, you will get long list of videos where they have highlighted that what are the failed products and why they have failed. So if the guidelines are not followed at the design stage, the product can fail. Now DFX has got different dimensions, as I have already highlighted: assembly, manufacturing, cost, service, safety, reliability. Now our focus today is design for environment. So sustainable composite materials means materials which are good for the environment. So how we can follow these guidelines? What is our model today? I think those from industry will definitely echo the same sentiments that I have. What is our model? Our model is take, make and waste model. So we take some material, first we identify who are going to be the raw material suppliers. In the morning, I think everyone has said it, there is a challenge to get the raw materials. So we take the raw materials, we make a product, we sell it in the market, and then our job is over. Normally we don't think what will happen to the product at the end of life. So that is not going to be the case in the next 10 to 15 years. There we will have to take responsibility of our product right from the launch in the market to what happens to the product at the end of life. I have just two sentences to say. One of our professors went to Japan and bought a second-hand car. So when he was coming back, he was not able to sell it again. He had to pay more money for disposing it off rather than the money that he spent for buying the car. So what I am trying to emphasize is, you as a user, you have to take the onus of the product, or as a manufacturer first you have to take, then as a user I have to take onus that what happens to my product at the end of life. So therefore these concepts become much more relevant, that we design a product in a way that it is reusable, it is recyclable, or you can remanufacture it. So therefore this concept of design for environment has come into being. So enormous amount of waste is created, and we have to see how we can eliminate this waste. This is the overall product life cycle. Our focus today will be on materials, as I have highlighted it. Then the materials will be made into a product which will be distributed, users will use it, and finally it will be disposed of. Now where design for and what we are doing at IIT Roorkee, we are trying to select raw materials which are natural in nature. These biopolymers are also available, these have been commercialized. Then we make samples. Then we make products with these samples. These are obviously not our products, but from the net. But whatever products we have made, I will try to show. And finally, at the end of life, what can be done? There can be, we can try to decompose them, and they get converted again into the natural ingredients. So this is a cycle which we try to analyze in our studies. So this is a very, very important diagram, and this chapter has been introduced in this book by Steven Pinker just maybe 10 years back. Earlier, this was a book, very famous book, Product Design and Development. But now this chapter on design for environment has been added. And if you see, this is a natural cycle on the left-hand side. And from nature, we are taking the materials, we produce a product, distribute it, use it, and then at recovery, we have to see what can be done with these materials. So this is, I think, a challenge. When we take the materials, what we can do, these are the guidelines, what we should do when we are designing a product. We must focus on renewable resources as it is given at the top. So when we choose materials for our product, we have to focus on materials coming from renewable resources. And when we decompose the products back into the natural cycle, we have to avoid the disposal of toxics and inorganics into the environment. We should focus on organics. So our first decision to choose a material for our product is very, very important, because if we choose a very, very environment friendly material for our product, then automatically at the end of life we will have less challenge to dispose it off into the environment. So therefore, first choice at the first decision regarding the materials, if we can do that, it will make our life easy. This is a summary of this. These are the challenges for plastics all over the world. Every year we celebrate the These are some of the case studies about the plastics. These are the single-use plastics. I will skip this. I think everyone is aware. So on World Environment Day, every year we try to focus on the environment. So what the composite industries can take from that is, we have to reduce the use of polymers, try to emphasize on reuse. Now reuse is only possible if your raw material is recyclable. If you talk about thermoset difficult to recycle, but then for thermosets also now there are a lot of strategies. You can pulverize it, grind it, and then mix it with some form of other material, use it as a filler. So you can have different strategies for recycling of thermosets also, but thermoplastics are easily recyclable. We have done a lot of work in recycling of thermoplastics also and published it. So if someone is interested, you can write to me, we can discuss it further. So what we are trying to do now is, with this reduce, reuse, we are trying to integrate the natural fibers with the thermoplastic polymers and trying to make composite materials which are natural fiber. So natural fiber reinforced polymer composites. So this is our concept now. We take a polymer, which is our matrix, which is biopolymer and biodegradable fibers, and combine them together. How we combine them, which I will be showing in the next slide, and then we try to make the biocomposites which are green in nature. So sustainable composite materials we are trying to emphasize on, which are renewable, recyclable and biodegradable. Now many times these materials are difficult to degrade, and biodegradable means that you will degrade them under a specific environment, maybe a composting environment. You have to create a pit, put the samples there and then investigate how this material will degrade. So all those aspects we are trying to analyze. One of the students has already completed a PhD on understanding that how these composite materials will degrade over a period of time. Maybe for 6 months, 1 year, 1.5 years, 2 years, what happens to the materials once. So that kind of studies are already we have done. This is a concept of natural fiber based composites. You can make partially green composites or fully green composites. Fibers are derived from nature. They are natural fibers. And we can even have hybrid, where you can have, many times we talk about the strength. I know this question will be coming to many of the delegates' mind, that this strength of carbon fiber is very high, glass fiber is very high. How these natural fibers will be able to attain that kind of strength? So therefore, initially only I told that these materials right now are being proposed for non-structural applications, high volume. On a table you have a stand which is made up of a plastic. Now you can replace that using a thermoplastic and using 30-40% of fibers. The fibers are also coming from maybe sugarcane waste fiber, or you can use rice husk, you can use wheat husk, you can use even in Uttarakhand and Himachal these days, not these days, maybe in the month of April, May and June, lot of forest fires, all of you may have read in the news or even seen in the television. Now these fires are caused because of the pine needles of the pine trees. Now these fiber, government is saying we are ready to give free of cost. Even we are ready to collect also, and we will supply wherever you want, because this is a menace, because it leads to the forest fires, and lot of our jungles are maybe subjected to fire. Even Forest Research Institute is doing a lot of research how to avoid this problem. We are also collaborating with Forest Research Institute in Dehradun and trying to develop the fire dosing tools. This year only 5 people lost lives during the jungle fires in the state of Uttarakhand. So this is natural resource which is freely available. Now if we can put 30% of this into making tables with biopolymer, this can be a good product which can be used by all of us, which will be a environment friendly, or we can say biodegradable product. So this is the concept through which we can have. The next slide will make it more clear. So if we have natural fibers and biopolymers, we can make fully biodegradable composite materials. But at the same time, there are non-biodegradable polymers like the ones that we use today, epoxy, then we use polyester. So if we have different types of non-biodegradable polymer, then we combine with glass fiber, carbon fiber, and make non-biodegradable composite. So in future, maybe we will see that there will be a transition from non-biodegradable to fully biodegradable composites without compromising the strength and the other requirements. And then this was the old practice, and this is the research trend now. Today also morning I was checking my email, 2-3 research articles have come, not only from India but from the globe, where people are focusing now on natural fibers all over the world. It's not only, but India has very large, you can say, flora and fauna, the kind of fibers. We are the biggest producer in many natural fibers as a country. So we can always leverage the potential that is the nature has already given us. Now only we have to think that how we can make entrepreneurs out of it and how we can make products out of it. So what we have done now, maybe another 10 minutes, we have this, because we are academic institute, our outcome is measured in terms of publication and in terms of technology transfer. So we do research in this area. These are the samples that we make, which are as per the ASTM standards. Different self-flexural impact testing samples we make. And this is the setup that we use. This is a direct injection molding setup, where you have a fiber, a polymer. Fiber is in the short form, therefore I told these cannot be used for very high strength applications. Where you need very high strength, you have to go for woven fiber as a reinforcement. But here we use short fibers. Natural fibers are available easily in this form. We mix the polymer and the polymer pellets and the fibers, and then mold them into the samples. These are the samples. Then we use the extrusion injection molding process also, where we extrude initially the fibers and polymer pellets into composite pellets, and then these composite pellets we use as raw material for injection molding and make the samples. This is a extrusion cum injection molding process. Same samples we have made here also. Then we can even use extrusion compression molding, where we extrude first a wire, then we take it to compression molding and compress it in the form of a plate, where we can get this type of composites in the form of tiles. So I'm not showing the mechanical characterization, but these are all the samples made by different processes: direct injection molding, extrusion injection molding, and extrusion compression molding. And if you see the effect of fiber loading on the right hand side, we can see you can a pure polymer composite thermoplastic, not a composite thermoplastic sample, 0 degree fiber, then 10 degree, 20 degree, 30 degree. So the color is also changing by addition of the natural fibers. These are some of the samples. We got a project from the top furniture manufacturing company in the country. So these were the products that we changed for them. The top one is the first product that they were making, a pure polymer product. Then we put 30% sugarcane fiber into it, and this is the product that came out. These are some of the products that we have developed. These are all child parts in a chair, different types of child parts that are used there. Then this is a flower pot which can be made. This is a pen stand which can be made with a natural fiber based compound. And you can even give different shapes depending upon the mold that you use. Then this ward separator also, during COVID we have developed this. This is not our image, but we have also developed a similar ward separator in which we have used a recycled this these coats that were used for the patients. Those were recycled and then they were used with jute fiber to make the composite. This is one chair with jute fiber and epoxy, which was made for just as a demonstration purpose of application of composite. Now this can undergo a lot of iterations. It can be further improved. I have already got this message for the time, so I'm just skipping some of the. उधर करना है? अच्छा, अभी आप बहुत लास्ट में आए बताने के लिए. कोई बात नहीं, we have to be happy. So now since all of you, many of you are from industry, and then sometimes we feel that X is an expert or Y is an expert in this field. Now, how to get in touch with that? And many times for academia, you feel that people charge IIT or other institutes charge a lot of money to provide the expertise. So one of my students has developed this software in which this is a process selection software in which a user can give the input. As you see at the top, the thermoset or thermoplastic, which material you want to choose, there is a drop down menu. Then the shape complexity or the process also, check the processes that are available from this table. You can see which shape closely relates to the product that you want to make. So based on all this information that the user will provide, he may not be having any technical knowledge. He may not even have heard of all these processes that are listed down there. So he is just an entrepreneur who wants to start doing business in the field of composite materials. So they can use this platform for selecting the right process for the composite material. So this we have done a case study on this chair only. Now this calculates based on the input. It calculates PCS, which is a process compatibility score for all the processes. Now all these processes that you see there, compression molding, hot pressing, reaction injection molding. So there is a long list of processes. It calculates a PCS score and a cost rating. Now many of you may be wondering how this software will work. So this PhD, she has already completed, a girl student, because in composites I thought lot of experimental work if you have to do, you have to go to the lab every day, spoil your hands working with the machines. Being a girl, although girls do better job than many of us when sincerity is concerned, but then she said, sir, I am from industrial engineering, I want to do something related to software. So then I said, okay, you do this job. And she has done a wonderful work in this, and this 2.5 to 3 years was only spent on collecting all the data available in the world in the field of composite materials and manufacturing of composite materials, processes related to composite. There are huge database that was created, and based on that, she used the artificial intelligence and machine learning algorithms to code this whole program. And this is a graphic user interface which was created for the composite industry, where the user may not be an expert. He would not like to spend 3 years to collect this data. He can or she can only put the input that I want to make this product. It resembles closely to this product, because if it is directly the same product, it will even give you a better result. So you choose the shape, you choose the volume, how many you want to make, you choose the materials that I want to make in thermoplastic or I want to make in thermoset. The software will calculate these two scores, the cost ranking and the process compatibility score. Then you can do a trade-off and select the best process. And the software will also provide you one summary of the process. For example, for making this, compression molding has been found out by the software. Compression molding process can fabricate the composite with higher fiber volume fraction, less than 60%, and type of products it can make. So it is kind of an expert system which can assist the entrepreneurs who want to venture into the field of composite materials. So now the last part, the future, where it can lead us to. These are all the samples that have been made, and if you see it showing as 25.98 grams, and if you cut that sprue part, it is 2.46. So almost 10% of the material is going as waste. So this 10% what we have done, this 10% we have collected, we have not disposed it off. For different samples, these are the samples which were fabricated, and with this process waste only, we have again recycled them into the samples and then again tested. So multiple time recycling was done. I am not showing the results here, but we have found out that 3 to 4 times if you recycle, 5 times also if you recycle, the properties of the resultant composite is better than the pure polymer. This is a thermoplastic polymer. So if you use a polymer, you get property X. If you add fibers into it, X plus delta X. But when you recycle it multiple times, still the property that you get is more than X. So it means that it is recyclable 3, 4, 5 times you recycle it, still you get the same properties which are better than the properties that you get with a pure polymer product. So which means that this is also published in an article. If someone is interested, write an email to me, I will share. Read the article, how it was done, what were the results that were achieved. But today I don't want to you can say barrage you with lot of data and strength and stiffness and all these values. Just a concept that this is a concept which may be in the composite industry in the next 10 to 15 years. Maybe it has already started, but then we will be seeing products which are, I have visited there was a Plast Focus exhibition in Delhi, I think 3-4 months back, and there were already 2-3 companies which have started making products which are using natural fibers and thermoplastics for making the mugs or for the tabletop products, or these type of companies have already started to entrepreneurs have already started to explore these ideas of sustainable products for making you can say money out of this concept. So with this, I think I will stop. Instead of 5, I think I have taken 7 or 8 minutes. So thank you very much. If there are few questions, you can ask me.